Hey y'all, I know many of y'all have been waiting patiently for updates on the R6 Jaeger ADS project, and I finally got one for y'all. I've returned from my exile of exams. So if we want to make a device that's going to fire a counter projectile to intercept a projectile, one of the most important things is the ignition system. Like, how are we going to get this counter projectile where it needs to go? So there are two main ideas that I originally had for how this could work. One was to have some sort of fuel injection and combustion system similar to like a potato launcher, and then the other was to have a mechanically loaded system with a spring or something like that. So thinking about the two options, my fear with the mechanically loaded scenario is it would be a difficult time to actually manufacture, and it would be kind of cumbersome, and it could make my assembly end up being very large. Whereas with the injection fuel combustion sort of way, the problem obviously is going to be safety, because if you don't make your pressure vessel correctly, you could do some damage. You could also, you're having fuel that's obviously flammable, so that incurs risk within itself. However, within the design process, I chose to pursue and do more research on the combustion side, because I really don't want this thing to get huge and cumbersome, and I thought that it would be very possible to be able to do these things, because hey, people do it with potato launchers all the time. So if I can make like a small version of the potato launcher, then hey, we're rocking and rolling. So first thing I got to try and make like a mini potato launcher was the PVC, because of course you're going to need PVC as your pressure vessel. I also got PVC glue to be able to seal it off, but this is what I was able to create. So this back section is the pressure vessel where you're going to inject the fuel, and then in this tube section you would put your counter projectile, and then you'd have a combustion reaction inside of the main pressure vessel, and then it would fire out. That's just a general idea. But it turned out when I was doing it that it just wouldn't work. And so let's dive deeper into why that might be. So one piece of the puzzle is, hey, what did we say about making stuff combust? We needed a spark. Why is that? When you're having a combustion reaction, there's a certain amount of energy that you gotta put into the reaction to be able to get the reaction started. It's kind of like when you're pulling the cord on your lawnmower to get it started, get it rolling. You got to do the same thing. That's usually in the form of a spark or some sort of lighter. So I bought like a spark igniter, like a thing you have in your barbecue on Amazon, and it would not work. It was the most frustrating thing. We modded this one so that we could get it to work, but originally it just had this one wire, and it had a single little prong with threads. So what we did is we threaded it into the top here. That's what this tape down thing is. We had two of them. So if I'm able to get this tape off, let's see. Okay, unfortunately I'm not able to get any of this off, but you can see that it's threaded in there right here. I actually had to drill into the PVC, and then this was able to thread into the actual PVC itself, so it's very, very much so secured in there. But this thing has the little prong that I was talking about that was connected to this button that has a battery. So in theory, right, it should be causing electricity to go within the wire, and then it should make a spark, right? Well, think about a circuit, right? The electricity wants to be able to get back to the battery. It wants to complete the circuit. So when you have just a single wire, not like this, but just a single wire going out, that's not going to let it complete the circuit. So you're not going to get that electricity jump. But what would happen is my friend and I, we'd be trying to get it to work, and then we'd accidentally touch somewhere near it, right? And then we do this. We do the little thing, and what happens is the current comes out of the battery into the tube itself, into us, through our body, and then back through our arm, back to the battery. So it would complete the circuit using us. And so we get shocked, and we'd be like, hey, but we got a spark, because we would get a spark, because it would jump across to complete the circuit. So what we figured out is, hey, if we create an almost complete circuit like this, like you see, the electricity comes out of here, it goes to these two prongs, and then it hops over and then comes back. So it's like a circuit with a cut in it. If we do something like that, it'll actually hop over these prongs and we can get a spark. So you'll see if I push this now, let me make sure y'all can see it. Did you see that? The electricity jumps across. So I said that was only half the issue, was the ignition. The other thing is the fuel. There's a lot of different fuels that you can use for these potato launcher kinds of things. You can get alcohol, you can get butane, propane, you can get pressurized air even sometimes to work. What I chose was alcohol because it was very readily available and I was able to get it in like an aerosol can as well. So I can spray it in here and it's not just going to sit as a liquid and it's going to actually kind of aerate and be able to combust within the air. But even then, it wasn't working consistently. And part of why that is the chemistry involved, called stoichiometry. So you need a certain ratio of the actual alcohol compared to the oxygen in order to get the combustion reaction. And you have to calculate it based on the volume. So the atmosphere is 21% oxygen by volume. So you do the ratio of molecules you need of alcohol to that of the oxygen in the air, and then based on that you can know what volume of alcohol you need. Even when I did that, it still wouldn't be consistent. And I think the reason why is just this is so big. This is such a big thing that having the right volume of alcohol is still just so much for this that our spark can't even ignite all of that. It doesn't provide enough energy to get over that energy hump. So after tinkering with this for quite a while, I decided to go smaller because I want my device to be smaller, right? So just to test things out, I took just a medicine bottle, right, and put a metal straw on it, and then stuck the spark generator inside of here, and I would open the cap and then spray the alcohol inside. This would ignite a lot more consistently, because I'm not having to put a copious amount of alcohol in there and then have this thing not be able to generate the spark necessary to actually make the reaction go off. So now it might seem like, hey, you got your stuff solved. All you have to do is refine it a little bit. Well, there's a few issues still that need to be addressed. One is the fact that since my device is so small, the projectile has to be even smaller. It has to fit inside of that straw, that metal straw. And so even if I get that to work, how much momentum does that kind of projectile actually have? If it has too little momentum, it's going to collide with the projectile that we're trying to stop, but it's not going to stop it. It's like a mosquito against a semi-truck. Like the semi-truck is still going to keep moving with its same velocity because that mosquito doesn't really have that much momentum to stop that collision. Another thing is the actual fuel that is used. Alcohol, of course, like we said, it combusts, but the thing about it is it burns for a long time. It expends all the energy and combustion over a long period of time, whereas stuff like propane, for instance, you combust it, all the energy is expended like that. And that creates a lot more pressure at one time, which makes it better for actually launching things out. Whereas alcohol, you'll get pressure, but it'll kind of put it over a long region of time, which doesn't do as good when you're trying to fire something quickly out. That's actually the reason why the medicine bottle is all deformed and stuff like this. It was a normal medicine bottle, but here, and I'll take this off. You can see the holes in the bottom for the spark generator and the straw. They're all melted as well. You can see the duct tape has melted. The entire thing is warped. And that was because we got the alcohol in there and we tested it out in here, and it burned for like 2 minutes straight instead of just combusting really fast and having all the fuel burn very quickly like that. Instead, it burned for like 2 minutes. This whole thing was caught on fire. It was kind of scary because it was in the house, so I was like, am I gonna burn the house down? But it was fine. We just took it outside, and yeah, it ended up being fine. I should have filmed all of these things. In the future, I will for my later testing, but yeah, that's what happened. So we tested out the combustion method, but also I said there's the mechanical method that would involve springs, things like that. And so I looked into those in like Nerf guns, for instance, because I own a lot of those, and those have similar mechanisms. But like I said earlier in the video, it ended up looking like it would take a lot of different parts to put together, and it would be kind of cumbersome. Also, getting a motor to work with that to be a trigger is kind of weird. So I don't really like the mechanical method either. So this kind of left me at an impasse for quite a while until I thought about a certain hobby that I used to enjoy when I was little, and that's paintball. So paintball launchers, they use CO2 canisters that are pressurized, and then it releases a little bit of the pressure to launch out the paintballs. And that should work, right? That should work just as well. So my idea was to, hey, maybe I can look at how paintball launchers work and try and engineer my own. And to actually fire it, I would create like a ball valve, and whenever it needs to fire, I'll have a motor that will open the valve for like a split second, releasing some of the pressure from the pressurized CO2. This is the idea that I actually also had for the combustion method, so that I could like have a tank of whatever fuel and then a valve, and it'll just open the valve whenever more fuel is needed to reload. However, just like the mechanical spring method, it would be kind of a lot to engineer the whole firing mechanism from scratch. And you also, when you're dealing with high pressure like that, your valves and things they need to pass certain specifications so that they just won't explode under the pressure. So that would be a lot to kind of deal with. So that could again make my design kind of cumbersome, take a while to actually make. So I thought about, hey, there are electric paintball launchers. Maybe if I can get like a cheap one, I can just install that into my design, like the whole assembly, put that in my design, and then open it up and wire it so that it'll launch whenever my control board tells it to. So that's my most recent idea. I have ordered the actual launcher itself from Amazon. It's just a cheap one that's electric. I'm not trying to break the bank, but yeah, that's where I'm at now. So I'm going to try and see how to wire that up so that I can tell it whenever I want it to fire. And this also allows me to have larger counter projectiles so they can actually counter the momentum of whatever projectile they're intercepting. And they come in more standard sizes than that small little straw tube. So I should be able to get a lot. And the other thing is paintball launchers, right? They're used for games, so you need to be able to reload stuff like that. So that also solves the problem of reloading the thing. You can just put a hopper with all your counter projectiles, and it'll just reload automatically. So that's my idea for now. Thank y'all for watching. I'll be making more videos with updates, and let me know if y'all have any ideas or want to see me do anything else. But thank you for watching, and I'll talk to y'all later.